Hello everyone, welcome to today's CRI Show webinar. I'm Emil and I will introduce you to today's webinar presenter and the topic. I'm happy to say that today we have Brian Noyes for the second time. He will be talking about WCF RIA Services and especially about validation. The webinar will take approximately 60 minutes, from which 15 minutes will be for a Q&A session. So please send your questions via the chat option in your webinar panel, and Brian will try to answer your questions in the Q&A session. Okay, and now Brian, please start the presentation.
Okay, welcome everyone, and thanks for coming to the webinar here. The topic, as I'm sure you know, is WCF RIA Services Validation functionality, and basically that is the part of RIA Services that allows you to put some validation in there when you're doing updating of your data, and we'll see there's several ways to go about that, and it provides a very easy to use and rich mechanism. A little background on myself. I'm from iDesign. We're a .NET architecture and design consulting and training company. I'm also a Microsoft Regional Director and a Microsoft MVP in the Silverlight category. So with that, let's just dive right into it. This is the same overview slide I showed last time, just in case there's a few people attending who didn't attend the previous one and have no exposure to WCF RIA Services. I'm not going to be going through a full overview in this one. I'm assuming you've had some basic exposure to RIA Services and what it's about. And last time I covered the query and update functionality at a high level. This time we're going to be drilling into, on the update side, the validation mechanisms. But just to kind of recap and set your mindset here, RIA Services is all about simplifying doing CRUD operations on entities and data from a Silverlight client. It's focused for line of business scenarios, and the diagram there is intended to depict that it tries to make sort of everything review the update mechanisms in RIA Services from last time. Basically, whenever you're doing updates in a Silverlight client, you're usually first going to have to retrieve the data to the client side from the server side, and so that means actually executing a query first. So when we jump into the code shortly, I'll just review quickly how the data is getting into the client from a query perspective. But assume that you go out, you make a call to the server, you pull back some entities, and you start showing them on the screen. And now the user is going to start interacting with those entities and updating them. There can be pure inserts, which is just adding new entities purely on the client side and just pushing them to the server side. But we're going to be looking at the mix of some combination of insert updates and deletes of the data that you've retrieved. After you've retrieved them, you use the thing called a domain context I talked about last time as your client-side object that you interact with that lets you talk to the server-side domain service. And whenever you do a retrieval, the data is actually cached underneath that domain context on the client side. And it's basically got this thing called an entity collection that tracks all the changes to the individual entities by basically subscribing to the property change notifications based on the iNotify property change interface that's standard in Silverlight and the .NET framework. So it's basically watching all the entities that have been retrieved, knows whenever you change properties, either the user changes it through the user interface or you programmatically change those properties, it's going to know about it through those property change notifications, and it's holding some state information off to the side about what's changed, so that when you go to do an update, it only sends down the stuff that's modified. It doesn't send everything back to the server. So any additions or removals from the collections themselves, child objects and child collections on those objects, or modifying properties to the individual entities will result in it knowing that these are things that have to be sent to the server when you tell it to. And then the way you tell it to update the server is by calling submit changes on the domain context object. And it basically bundles up all those modified entities into a batch called an entity set object, and it sends that down in the service call to the domain service on the server side. Once the server side receives it, it's basically a single method that gets called on your domain service called submit, although you don't typically have to override that. What you do is you provide insert, update, and delete methods that take an individual entity, and the base class will basically rip through the entity set that's sent down, basically set up a for each loop effectively on the collection. And for each entity that's sent down, it'll look at the state information to see whether it was an insert, update, or delete, and it will call the appropriate method on the domain service. So we'll see all this in code here shortly. I just wanted to review the basic process. So let me jump into the code real quickly here and review what I just said in words. The sample application I'm using today is the sample app from part 6 of my article series. I should have mentioned that up front. This is all based off of an article series I've done. If you haven't stumbled across that yet, there's a 10-part series on the silverlightshow.net on WCF RIA Services covering all the major aspects of RIA Services. And so this is mostly, this seminar is mostly focused on part 6 of that series, the validation mechanisms, but I'm also kind of reviewing some stuff from preceding articles as well. So the sample app here is focused around the entities we're dealing with. The root entity is called a task. Think about a to-do list type of application here. And along with tasks are time entries down at the bottom of the screen here. You can see that there's a place to display time entries. Each task can have a customer associated with it, and that's displayed down at the bottom of the screen here. And those are the primary entities we'll be dealing with today. You can see at the top of the screen I've got the ability to add a task and save changes to anything that's been modified on the client side. I've also got down at the bottom the ability to add customers and select customers and add time entries and delete them. So basic CRUD type operations on entities here. And so the code to retrieve the entities in the first place, this app is broken up using the MVVM pattern, model view view model pattern. So all the logic code is in the view model here. You don't have to know a whole lot about that pattern to follow along today. But if you want more background on that, part 4, I believe it is, in the series talks about breaking up into the MVVM pattern with RIA services. And so basically down here you can see when my view model is constructed, which is pretty much when the form loads up, I invoke a load operation on the, well, that's actually for the customers, and this one's for the tasks themselves. So I invoke a load operation on the context here, and this context is that domain context type that I talked about. You get a specific domain context type for each of the entities that you expose from your domain service with query operations. So invoking the load operation here is what pulls it down to the client side, as I covered last time. Then once it's there, like I mentioned, it's cached and presented on the screen through data bindings. And then eventually you punch in some new values and you want to send changes back. And so all I've got in the form, you saw there was a Save Changes button at the top of the form. And then we've got a handling method here in the view model. And basically you can see that all it does is this one line of code. It goes up to the domain context and it calls submit changes. And this thing has several overloads to it, but what I'm doing here is just pointing to a callback handler, because all the operations, as I mentioned last time, all the operations that you invoke on your domain context that result in server calls are done asynchronously, which is a general requirement in Silverlight. So submit changes is a non-blocking call. I point to my callback handler there to say what do I want to do when the call is complete. And you can see mainly what I'm doing down there is checking for errors, and we'll get to the details of that code in a bit. So that's the basic query and update pattern of RIA services, which I covered in more detail last time. So let me run this real quickly just so you can see the functionality in action here. I'll fire it up here. You can see it downloaded when that load operation was invoked. It downloaded. There's 4 tasks currently in my database, and it downloads those asynchronously and updates the UI once they're downloaded. And then I can go to a particular entry here, or task, and I can add a time entry. Now right off the bat you can see some of the validation at work here is that I've got this description field on the time entry set to be a required field. And this one I'm using, one of the mechanisms is to use attributes. So it's requiring that field, and it does the standard Silverlight prompting here for a validation error. And I can put in a description and click add here, and now it shows up down here at the bottom as the time entry. I can also add multiple time entries there, and then it's when I click Save Changes up here that those changes are going to be persisted back to the back end. Now in this case, you can see I don't have any errors, so it would actually do nothing in the callback handler, and that change was persisted in that process. So that's the basic query and updating. So let me jump back to the slides for a moment, and let's talk about what we have available to start validating those inputs. Oops. So first off, in general, in Silverlight, whether you're using RIA services or not, you've got several options available for doing validation, and the primary one that RIA services is leveraging here is that anytime you use a data binding in the Silverlight UI, it will inspect the object it's bound to and see if it implements an interface called iNotifyDataErrorInfo. And this interface is designed to support asynchronous checking for errors. You can see it's got 3 members there. Basically what's going to happen here is the bindings, whenever you set a property, it's going to check and see whether there's errors associated with that property by calling the getErrors method with the property name. Now at the moment you set that property, it may not have any errors yet because it may have to make a round trip to the back end to check for errors, and that's always got to be asynchronous in Silverlight. So the event there, errors changed, so that it can fire that after the fact and notify the binding that the errors have changed, and then the binding can requery and see if there's any errors to be had. And of course the flag at the top there has errors is just for efficiency, so it'll first check and see whether there's any errors before it bothers invoking getErrors. So what happens here is the RIA services entities, when you create your entities on the server side and you do your compilation, which I showed last time, you get client-side definitions of those entities that work in the Silverlight application. And there is an entity base class on those generated classes that's part of the RIA services framework. And it's that entity base class that has the implementation of iNotifyDataErrorInfo all kind of wired up and ready to go on your entity, so you don't have to do anything to support this. Just by binding to the entities returned by RIA services, you get this functionality for free. And then in terms of how you decide what errors there are, there's really 3 main mechanisms that you can use here. The first one I'm going to look at is using data annotation attributes. The second one I'll go through is when you need to look things up on the server side, because not all things can be determined on the client side. And then the third one I'll look at is, again, when you got to look it up on the server side, but you don't actually want to wait until you invoke the save or submit changes method. You want to do it kind of immediately on the client side, but you got to do that async since it's a service call. So we'll look at all 3 of those in detail here. The first one, the data annotations, is based on a standard namespace in .NET and Silverlight called system.componentmodel.dataAnnotations. And RIA Services is not the only thing that knows about these. ASP.NET MVC and dynamic data features are also able to tie in automatically to using these data annotation attributes. And you can also use it in just about anywhere in the framework, such as WPF or Silverlight on its own. You could do this with some base class code where there's about 3 lines of code you have to write to go check these attributes. Basically what you've got built in as far as attributes are shown here. There's one, that description field I showed that was indicating a validation error. I'm using a required attribute, and you just put that on a property, and it basically says you've got to provide a value for that property. You can use a range attribute on a numeric input and specify a min and max value, and that will tie right in and show those validation errors if you exceed those. You can use a regular expression one, which will basically take a regular expression as an argument, and it will evaluate the value that you set on that property based on that regular expression, typically for string type inputs. And then string length also for string inputs when you want to limit how long the string can be. So that's all that's really built in, but for everything else, there's the custom validation attribute. And with that attribute, you can basically point to a static method that has the signature shown below, and then inside that method, you can do whatever you need to do. So I'll show an example of this where you can do this just for, a computational type of validation that you can't easily express with those 4 attributes above. You can also use it for cross-field validations when you have property A depends on property B in some object, and whenever you set A, you got to check B and vice versa. You can easily accommodate those kind of scenarios with a custom validation attribute, which I'm doing in the sample. All right. And with the data annotation attributes, basically once you put those on your entities, RIA Services is going to automatically look for those and will evaluate them in that base class implementation of the data of the entity class rather. It's going to look for those data annotation attributes and use them for its implementation of iNotify data error info. The server side, the entity framework, is going to, depending on how you generate your data access layer, with Entity Framework you have a lot of different options. You can do database first, you can do model first, you can do POCO based entities, you can do the new code first, as they're calling it, in Entity Framework 4.1, which is due out soon. You can go to the ADO.net team blog and find out some information on that. So there's different ways of getting your model defined in Entity Framework, but if you use one of the approaches where Entity Framework generates the entity classes, then you can't go modify the properties directly since it's all generated code. But what you can do is use something called a metadata class, and I'll show that as well. And you can put the properties on the metadata class and they get evaluated by RIA Services automatically. So you basically get both client and server-side validation, and the server-side stuff is there. It should never be invoked if your only client is the RIA Services client, because the client side is going to enforce it, and you shouldn't call save if you've got validation errors. But if it does get invoked, if you don't code things up that way, or realize that your domain services could be invoked by any client because they are exposed as WCF services, as REST-based services. So theoretically, other clients can come along and invoke those, and especially if you expose the additional endpoints that are capable with SOAP-based endpoints and JSON REST-based endpoints or OData endpoints, they can be invoked other ways. So you always want to validate on the server side, even if the client side validates, and RIA Services does that. If you do use the custom validation mechanism I showed, those static method definitions that you have to define will have to be present on the client side. And the way you get that done is with a shared file. I'll show that in the code. You can basically declare code files on the server side with the .shared naming convention, and they will get automatically code generated on the client side as well. So you get sharing of code between both sides with a single definition. All right, so let's go take a look at the code that uses data annotation attributes. Well, the first one we can start with is the description field that I showed when I was trying to add a time entry. So just to refresh your memory here, let me run the app again real quick. And go select this bottom thing and try to add another time entry, and you can see here for that time entry I've got the description field is required as an automatic prompt, and it's got the red highlighting border there. These borders, the appearance of a validation exception or a validation error is built into the Silverlight controls, and if you buy third-party control sets, they should have it built in as well. It's all built on a standard mechanism using visual states and things that are part of Silverlight. And you can customize that through control templates. So the way you actually get that to, define that you want that to be a required field is the simple declarative approach with these data annotation attributes. First off, wherever you have your entity type defined, you're going to need to have this reference to the system component model data annotations namespace. And so that's brought in by default when you define your RIA services. And then on the entity type itself, you're going to, I'm going to kind of skip over some glue here and I'll come back to it. But wherever that property is defined, let me find my time entry. You can see here's a description property and I just put a required attribute on that property. Now, the stuff I skipped over here is, if you look closely, the place where this description property is defined is not on the time entry itself. It's on this time entry metadata class. And the reason for that is that I am using entity framework generated entities. And so the actual description property is part of the entity model, and I can't so modify that code. So what they have is a concept that's called buddy classes. If I could interrupt for a second here, email, I'm getting a notification here that the audio quality is poor. Am I coming through okay? Can anyone hear me?
Sorry, Brian, do you hear me? It's
Yes.
You sound okay. There's no problem.
Okay. Okay. Sorry for the interruption, folks. I just wanted to make sure I wasn't talking into the void here. Okay, so back to our regularly scheduled programming here. So the description property here is on this metadata class, and what happens is through this attribute at the top, you can see what I've done is defined a partial class time entry, and so it will join in with the partial class definition that is co-generated by Entity Framework, and this attribute basically allows me to associate what's called a buddy class or a metadata class, which is just, the convention is to just define that as a nested internal sealed class, but it doesn't have to be that structure. That's just the convention. And what it basically does logically is it merges any attributes defined on the corresponding property. So on the real-time entry, there is a string description property. It basically lifts off the attributes that are defined on this one and tacks them on to the definition of the other partial class as far as RIA services is concerned. And also this is the same mechanism that ASP.NET Dynamic Data and MVC use as well. So it just allows me to tack on these attributes to the property by redefining the property on a metadata class. You can see here in the same file, I didn't show this in the demo yet, but I've got a couple other places in the app that I'm doing the same thing. So when I go to add a customer, I need to input a phone number, and so I've got not only a regular expression-based thing that's enforcing US phone number format, which we have 3 characters, and 4 characters for our phone numbers as a standard with various kinds of separators. And that's basically what this regular expression represents. And then I've also got one of these custom validations hooked up. And you can see the structure here is you use the custom validation attribute. You point to a type where the static method lives, and then you pass the method name as a string. So unfortunately there's not compile time checking there. If you do a refactor rename, this can break, but hopefully you'll pick that up in your refactor rename tools. So this is pointing out to this separate class, customer phone validator, and you can see I've got a couple of methods in here that we're being pointed to. They always have to have this signature where it's a public static, returns a validation result object. Doesn't matter what the name is because you point to that with the magic string and the attribute. And then the first parameter is always going to be the value that is being set on the property that needs to be validated. The second parameter is this validation context object. And this thing brings you, as its name implies, it gives you a little bit more information about what's going on in the validation. Specifically, it's got the most useful property on there probably is it's got a property for the object instance. So the parent object, basically, the value that's going to be passed into your validation method here is just the value that's being set for the property. That object property on the validation context will give you a reference to the whole object on which it's being set. So for those cross-field validations, which is exactly what I've got going on here, I've got two different properties on my customer. Now this is kind of contrived just to demonstrate the mechanism, but I've got a Boolean property called hasPhone, and I've got a property called phone. So obviously if you say true hasPhone, then the phone property should be set. And if you say false hasPhone, then the phone property should not be set. And that's the basic logic I'm trying to implement here. So over here in the validation method, I have to go and basically check both the property that's being set. In the first method, it's phone. In the second method, it's the hasPhone property. I have to check that against the other property. And so by going through the object instance property on the validation context, I can get to the whole object customer and get to the other properties on that customer to do these type of comparisons. And then the helper method down here just checks, whether both properties are set in a consistent way. And you can see what you return is a validation result object. It has a static value called success if you want to return success. If you want to return an error, then it requires you to construct a validation result, pass in an error string, and then you can pass in what properties, and you can see it's a string array, so you can pass in what properties this affects. So this affects the validation on both the hasPhone and phone property, even though only one of those is set at a time. So pretty flexible mechanism here. And also notice at the top here in the tab, this file is a .shared.cs file. So when I declare it that way on the server side, if I look here in my server-side project, in the web project, I've got this customer phone validator.shared.cs. And then when I compile over in the generated code folder on the client side, I get that same exact class generated. So anything with a .shared.cs or .shared.vb file extension on it will be automatically copied over to the client side, so that those same attributes get merged onto the entity. Oops, that's another shared. When I go to the actual, excuse the cough, go to the actual task class that's generated on the client side. Actually, the one we're working with here is a customer. So the customer object on the client side, we go to, for example, the hasPhone property, and you can see it's got that same custom validation hookup on the client side, and it's able to resolve this type because of the generated code that gets that customer phone validator onto the client side as well. So any of these attributes that you define server side, they show up client side, and they'll be evaluated on both sides by RIA services. So just to run again real quick, you saw the screen one already. Let me show you where the customer one comes in. If I select a task, and down here I say I want to add a customer, and I start putting in some stuff, we'll call this one Joe. And as soon as I start putting in a phone number here, you can see obviously not a great user experience here. It's more to show the mechanisms. But I'm getting validation errors on not only the phone field that I was putting in a value for, now the hasPhone field also has a validation error. And I put a validation summary into the form, that's a control in Silverlight, to show all the current validation errors, show that you can have more than one. So I've got one for the regular expression showing up because it doesn't comply with the phone number format. I've got one on the phone property because hasPhone is not set, but I'm providing a value. And then I've got one on the hasPhone property complaining because the value is on phone and hasPhone is not set. So obviously overkill here from a user experience perspective, but more to show the full range of mechanisms that are available to you. And then if I get myself to a valid phone format for the US and then go check the box on hasPhone, then everything's consistent and all the validation errors go away. And if I have some inconsistency on just the phone number, then only that one would apply. So you can see, ties right in with the Silverlight validation mechanisms, all with just a couple of attributes and possibly some custom validation code. So let me switch back to the slides again, and we'll talk about the next mechanism. The next choice you have is sometimes you can't do things purely statically in code. Sometimes you have to actually go do a lookup to figure out if a valid or if an entry is valid, basically. Think about a customer-based scenario like this, and the one I have wired up here is that I've got some customer status associated with each customer, and I'm a consultant, I live on a billable hour basis, and if I've got a customer who's really bad about paying, I don't necessarily want to rack up hundreds and hundreds of hours to be billed if I know that they may not pay. So I'm probably going to bill them on a more frequent basis or not allow too many hours to be input for that customer. So in my tasks and time entry type scenario here, what I've got wired up is that I need to look up the customer status to decide, have I put in too many time entries for this customer? Now, that kind of information usually requires a lookup on the server side. You're not necessarily going to want to transmit all the status of everything to do with your entire system to the client. So, hold on just a sec for a coughing fit. So those are the kinds of things you'll want to defer and not do the validation immediately, but possibly wait until the point where you try to save. And then let the server do the lookups, decide whether it's happy with the things that were submitted to the server side, and then if it's not happy, it needs to indicate it back to the client, and you still want to have a consistent indication to the user of invalid data. So basically what you can do is when you call submit changes and that batch is sent down to the domain service, you can put whatever kind of rules you want into your insert, update, and delete methods to check the values that were submitted. And if you're not happy with any of those values, all you need to do is throw a validation exception. Once you do, RIA Services will basically intercept that. It'll return it to the client, and it will associate the validation exception with the entity on which it was thrown. And you'll get the same kind of validation indications on the client side. It'll tie right in with the Silverlight validation mechanisms. Because it is an exception explicitly thrown from the server side, it does show up as an error on the client side, so you have to handle that, and I'll review the code for that here in a moment. You'll have to handle the exception so it doesn't blow up your app, but you don't have to do anything extra in terms of associating that error with the entity it was thrown for. That all happens automatically through RIA Services. If you want to do more low-level kind of interaction with what errors occurred and programmatically do things about it, you can interact with, in the completion of the submit operation, there's an entities in error collection that's exposed from the event the arguments that get passed to that callback, and you can inspect that and do whatever you want based on that. So let's take a look at what this code looks like. Okay, so I'm going to stop debugging for a moment here and jump into the server side. So when I do a submit, I come into my domain service here, and I've got the individual insert, update, and delete type methods interwoven here in the code. Okay, so for each entity type, if you want it to be updatable, then you'll provide these insert, update, and delete methods. And as I covered last time, you can see each one of those is defined with a single entity object as an argument, and that's where I described up front that it will basically loop over the change set that was sent down and invoke each one of these in turn with each entity. So this is where you can tie in some logic if you want. And so, for example, you can see up here in my update task method, I've got some validation that occurs. First off, I've got this validation method that says validate customer hours, and this is the one we're going to focus on here. So if I drill down, oops, hit the wrong button, stand by. If I drill down to the method, you can see that there's some logic here that says, okay, if there is a customer ID associated with this task, I am going to go look up, call another method here, and do a lookup to see how much total time is associated with that customer. And if it exceeds some threshold, in this case I've got it hard-coded to 10 hours for bad customers basically, which I have labeled as a status of deadbeat in the database. So basically, if it exceeds that, you can see in this is total time allowed method, it just goes through the entity framework to the customers table, looks up that customer, and then once it's got it, it's going to check the customer status for that customer. If they're a deadbeat and their total time exceeds 10 hours, then it's going to return false from this method, which will cause a validation exception to be thrown from the calling method. And the reason for this structure here we'll come back to in the next portion has to do with this invoke attribute. So this is called both from the client side and from the server side, is why it's broken up this way. But focusing on this mechanism, if you throw a validation exception, basically RIA Services knows that it's in the process of trying to update a single task. And so when you throw that validation exception, it's going to catch it up in its loop basically, where it's looping through all the entities in the change set. And it's going to pass some information back to the client side about the fact that this validation exception was thrown for this particular entity. And it will carry along the error message that you include as well. And so when this is invoked, I can set a breakpoint here. So we see it at runtime. And I'll go try to put in too many hours for a deadbeat customer. So the first step is select a task, and down at the bottom of the screen I select a customer. Now it just so happens I've got set up at the database level in the status field, I've got the Brian customer set up as a deadbeat. So I select that as a customer. Client side doesn't have to know about that, it just knows what customers are available. And once I have a customer affiliated, you can see we already have one time entry here that's about 2 hours long. I'll add another time entry that's a bit longer so that we exceed the 10-hour threshold. Got to put in a description for that. Now the client side at this point is fat, dumb, and happy. It doesn't happen to know that this rule exists. It's at the point where I go up here to the top and I press Save Changes. And now you can see we jumped over to the server side. We're in the domain service and we're on that validation method, and this validation exception is about to be thrown because we exceeded the total time of 10 hours across all the time entries associated with this task because the customer is a deadbeat. So we just throw that exception. You can see it's being thrown on the server side. I pressed F5 here to continue to run. Now we're back on the client side in the view model that made the submit changes call in its callback handler that we looked at before. And now if we look at this has error flag on the submit operation argument that comes through, it's got a flag that says yes, in fact, there is an error, meaning an exception was thrown on the server side. And so if I look at this entities and error collection on the argument as well, we can see that if I expand the results, there are in fact 4 tasks that had results on them. And I won't drill down this way, but we can just run past this and you can see I'm doing a debug write line with the error messages. So it's going to loop through all the entities in error. It's going to find the validation errors associated with them, and it's going to go ahead and pump out that error message to the output window. So let me just hit F5 here and go back to Visual Studio, bring up the output window, scroll up a little bit, and you can see this text that came back from the server side. You cannot enter, yada yada. Okay. Now right now if I switch back to the UI, nothing is showing. Now this just has to do with the way the data grid works. Is the only place that task is really showing is in the data grid, and the data grid by default does not show validation errors unless you are in edit mode on a row. So if I click on this row and click on it again so I go into edit mode, you can see that in fact the validation error is there. So it depends on the way you display this, and there are ways to switch the grid to show those even if you're not in edit mode. But you can see that the validation exception got automatically associated with the appropriate entity, and it's showing that validation error message as the error message associated with it. So pretty slick mechanism there. All you got to do is just some simple logic code on the server side inside of your domain service method, and then throw a validation exception, and it gets handled back on the client side by the framework. Now, the one piece I glossed over there is this line of code is very important. I think I mentioned this last time, but let me reemphasize it. Whenever you do a method call through a domain context in RIA services, as I mentioned, they're always async, and you get a completion when the async operation is done. If you don't handle that through a callback like this, or there's also a completed event you can handle, if it was an exception that was thrown on the server side, it's going to rethrow that exception on the client-side thread. And any unhandled exception like that in the Silverlight app will blow up your application. So what you always want to get in the habit pattern of doing is generally you always want to do a callback or a completed event handler for your async operations. You want to check if there's an error, do something appropriate, and then mark the error as handled as this line of code does, and that will prevent it from being raised as an exception on the thread and blowing up your application. So that's something you'll have to do anytime you're throwing these validation exceptions on the server side. All right, and then one last mechanism to cover before we get into the Q&A, and that is being able to not have to wait until you do submit changes. If it's still up to the server to make a determination on validity, but you don't want to have to wait until you do submit changes and send a whole batch down and then have problems with that batch. You can actually do asynchronous calls from the client at any time using something called an invoke method. And you saw when I was covering the domain service, I'll go back to it in a moment, I had a method that had an invoke attribute on it. Anytime you declare a method like that in domain service, you can call that directly from the client side on your domain context. It basically just becomes an exposed service method on your service that can be called at any time. There are some limitations to the parameters of that. It basically has to take simple type parameters, non-entity type parameters. So you'll generally send a single property value down for this scenario to an invoke method and then get a Boolean type result back to find out whether something is valid. And then, once you get back an invalid indication, then you can do whatever is appropriate on the client side. You could pop up a message box as one way, show a pop-up of some sort, or just set the validation errors manually so that they show up in the normal way. So let me jump back to the code and show you where this is going on. If I stop debugging here, I'm going to change out a method in my view model here. You can see some commented out code here. Just bring this code back in, kind of a long method, but we'll talk through what it's doing, and I'll get rid of the existing one. So this is 4 time entries. Basically the idea is I want to validate as soon as I put in a new time entry. I want to go make an async call to the server, and if I've exceeded that allocation based on the customer status, so I put in a new time entry here, and I'm going to break that 10-hour limit. Probably got to do more hours than that. Okay, I want to have a validation indication. Now in this case, I got 10 hours there. Why didn't I get it? Oh, because I didn't have a customer selected down below. Let me just refresh this app without saving. Let me select the customer first to the customer that's got a deadbeat status, and then let me add the time entry. Okay, so now I exceed the 10 hours and I immediately get prompted here with a message box saying can't have more than 10 hours for this customer. It doesn't say why, it doesn't transmit that there's a deadbeat status, just says you can't do it. Okay, and in this case I've got it coded so it doesn't let me leave the time entry unless the entry is less than that allotment, so I can just cancel out of there. So the way that's happening is if I go back to the code, and I'll stop debugging here so we can see what we're doing, and go full screen on the code. Okay, a whole bunch of goop here, and first off, for those that are well-versed in the MVVM pattern, forgive my evil sins here. Okay, I'm doing a direct pop-up from my view model, which is really a bad idea in the MVVM pattern, but it was just so I didn't have to put a whole bunch of infrastructure down that had nothing to do with the sample. So basically what I'm doing here is I'm putting that pop-up on the screen as a child window. And then I have to wait till I get a closed indication on it, and then I can try to process what was put into that child window. What you can see I'm doing here, once I get down to a certain level, I won't go through every line of code here, is I get a domain context reference, and I set up a callback here that I'm going to pass to it for when the call is complete. Okay, so I'm just setting up the delegate of what I want to do when this invoke method is complete. And then I actually call the invoke method, which was that is total time allowed. If you remember that in the domain service, jump back over there real quick. Remember this method down here was where I was actually doing the database lookup and comparing with the rule that said no more than 10 hours for a deadbeat customer. Just by virtue of the fact that I make that public, take simple type parameters and put an invoke attribute on it, it shows up on the client side on my domain context as something that can be called directly. So then on an instance of that domain context, I can just invoke that method. It is a non-blocking asynchronous method, which is why I need the callback here for when it's complete. And that callback is just being passed as a parameter to the method invocation here. And I pass in the current customer ID value and the sum of all the time entries. Basically, this expression is really giving me the sum of all the time entries on the current selected task plus the new one that was just entered. And I pass that down to the server, do the lookup, and I get back a Boolean result. But because it's an async operation, the Boolean result comes into the callback. It doesn't come back immediately from the method. So the callback, you can see, gets passed in a bool. I can check that bool through the value property on this argument. And then if I get back a false, basically, I'm going to say that it said, no, it's not allowed. And that's where you can see I'm showing a message box. Now, if you want to do it a little bit more integrated instead of popping up a message box, what I can do here is comment out these 2 lines of code and replace them with these 2 lines of code. And what those 2 lines of code are doing is, instead of just popping a message box, what I'm doing is taking the current task, going to its validation errors collection, which is on the base class that RIA Services contributes, doing an add, and putting a new validation result object inside of there with an error string. Okay, so this is basically what happens under the covers automatically for you when you throw a server-side validation exception or when the validation attributes are evaluated. But you can do it manually yourself here based on one of these async calls and just stuff it onto that task object. And then as long as there's an entry there, I'm going ahead and putting it onto, even though it's in an invalid state, I'm adding it to the collection so it can be displayed and dismissing the pop-up that allowed me to add that. So now when I run this code, we'll see a little bit different behavior. It looks more like the other cases where I go to a task, I try to add my time entry, I put in a time that exceeds. When I click add there, behind the scenes it made an async call, figured out that there was a validation error, and it's not working the way I expected. I should be seeing a validation error when I click on this. Oh, it's the same problem again. I don't have a customer selected. So let me refresh again. Obviously, this is not a bulletproof, ready-to-ship application in terms of the customer selection down here. Let me select my customer again, then add the time entry. And then when I click add, the async call goes out. And if I put this thing into editable mode, it's still not doing what I'd expect. Is my sum here 7 plus 2? That's why. Let me add one more time entry to push it over the limit. And now, when I put it into edit mode, we see the validation exception shows up, or validation result shows up there. So that's another way you can do it, just to add it into the validation errors collection of the entity, and it will tie in directly into the binding validation mechanisms. All right, and that's basically it. Let me go back to the slides momentarily, and then we'll get into Q&A. So in summary, you can see very rich mechanisms there that tie in to the native Silverlight binding mechanisms very cleanly. You can choose to use the data annotation attributes. You can use server validation logic in your insert, update, and delete methods and just throw a validation exception. Or you can make async service calls to an invoke method from the client and tie it in however you want on the client side. If you want more written backup of what I've covered here, you can check out my series, particularly part 6 of that focuses on the validation mechanisms, but some of the other stuff I covered here today is from the first excuse me, the first 5 articles as well. With that, I'll switch gears here and take some questions. So let me bring my panel out here so I can see what we got. Just kind of expanding things so I can see. The first question I have here is, since the validation application block has been ported to Silverlight, should we be looking at it as another way of validating? Any thoughts? Well, Jason, here's the thing, is if you look closely at what they did in Enterprise Library 5, all they did is they ported their own code to use the data annotation attributes under the covers. So personally, I wouldn't use the validation application block. They do a few other things besides what's shown here. I actually have not tried to see if that works directly with this RIA Services stuff, so I'd have to give that a check. But generally, the stuff the validation application block does now is all kind of been incorporated into the framework, into the data annotation stuff I showed. So a lot of the purpose of using validation application block is gone now. The next question here, you mentioned it was possible to use data annotation attributes within any .NET project using 3 lines of code. Do I have that at hand? Why, yes, I do. Just give me a second here and I can call it up really quickly. This is part of my Silverlight class here. I'll just go to a demo, data binding, actually a different class. Here is a, let me just bring up this sample real quick to show everyone. When I referred to just about 3 lines of code in a base class, you can either put it on the entity base class itself, you control of that, or if you're exposing properties from a view model, you can put it on a view model base class. But basically what you do is you have to come up with one of those validation context objects, and you call a static method on a validation class. So in this sample here, I've got this entity base that's on each one of my entities, and these are the 3 lines of code I was referring to, is that I expose a method that my derived classes can call from their property set blocks, passing in the property name and the value that's being set. I construct a validation context. Let me go full screen on that. Construct a validation context with a reference to the object itself. The other 2 parameters I won't get into. Pass the property name into the member name property of that validation context, and then pass that context to this validate property method on a validator class. Simple as that. Now it will basically go and reflect on the object, find the attributes, and evaluate the roles that those represent. All right, let me just put the slide back up there in case anyone wants the links there while I move on. Next question, do you transfer your entity models over WCF, or do you use data transfer objects? Well, when you're using RIA services, it's really close to the data transfer object pattern. What you really do is you define entity types on the server side, either through Entity Framework or on your own through what's called POCO, or plain old CLR objects. You define your entities on the server side, and through the code generation mechanisms of RIA services, they define a client-side equivalent to that. And so WCF is used with data contracts under the covers to serialize those objects pass them over the wire and rehydrate them on the client side or the server side, depending on which direction you're going. So it really, your entities are acting as data transfer objects from a patterns perspective. But through partial classes and through the base classes, there's more to those objects than being a pure data transfer object. There's a question here. Is there a way to show a validation box directly under the last control on the form without having a slider show for both the slider and error box? I'm not 100% following the question, but the bottom line is, as I mentioned, the default presentation of validations is built into the Silverlight controls, into their control template. You can create a custom control template starting with the existing template. Blend has a very easy way to do this. If you select a control, right-click on it and say Edit Template, Edit a Copy, it basically gives you the existing control template as the starting point, and then you can modify it from there. So if it's a customization of what you see on a single control, then you can go modify the control template. If it's if I'm reading your question right, it sounds like more along the lines of the validation summary, which is a separate control that's in the Silverlight toolkit, I believe. I forget whether it's in the SDK or the toolkit, but you can put that on a form, and it will find all the validation errors for all the controls on the form, and I showed that in that one dialog. So that's another option. From there, you would have to just kind of write your own code to go probe all the bindings and find their entities and find their interact with the I notified data or info interface. It'd be a lot of work to do something beyond that. All right, next question is, does RIA Services implement anemic model or rich models? It kind of depends on what you mean by anemic or rich, but I think what you're saying is some people prefer entities that are very lightweight, and some people prefer entities that are really business objects in the sense of like a CSLA business object, where the object is not only contains the data, but it contains all of the rules associated with that data, and also does its own persistence. Sometimes it definitely doesn't go to the end of the object doing its own persistence. It wants your domain service to invoke persistence based on the entities that flow into it. So even though there's probably a way to define those entities where you could do it that way, it doesn't support that full end of rich models. But certainly you can see with the validation mechanisms here, you can easily embed rules on the objects themselves with these attributes. Through partial classes on the entities, you could potentially have other methods that get called, but it's more on the side of what you're calling an anemic model, or what I would call lightweight entities, than a rich domain model. All right, the next question is says a little bit off topic, but does RIA Services work nicely with test-driven development? I have got one of the articles in my series, I believe it is number 7 or 8, I forget off the top of my head. Part 7 or 8 talks about testability a little bit. I also touch on it in part 4 when I cover the MVVM pattern. You can definitely unit test things that are using your RIA service stuff on the client side. I wouldn't say it's simple because, and it's not really, I haven't been able to come up with a better way myself to recommend to the RIA service team. So it's that you've got an object there, the domain context object is doing a lot of stuff for you. As I mentioned, it's caching the entities that you retrieve, it's doing change detection on those entities, it's making the asynchronous calls for you, it's affiliating validation errors with the entities. There's a lot going on under the covers of that thing. So mocking out what that thing does is kind of complicated. Plus the fact that you've got an async API there is always a little complicated in terms of mocking. So if you're talking good test-driven development with good mocking of dependencies, yes, there is a way to do it. I cover it in my article series. No, it's not particularly pretty because of the complexities of what's going on inside your domain context. Okay, next question is it possible to use RIA services with Microsoft Dynamics CRM? I would not be able to answer that. I'm not a dynamics guy. I would have to go look that up. If you want to follow, I know a couple of CRM experts. So Luciano, if you want to contact me by email, you can see my contact info there on the screen. I'd be glad to try to get that answer for you from a dynamics expert, but I know almost nothing about dynamics myself. Any other questions? We're right at wrap time, and the question queue is empty at this point. So let's do this. I'll go ahead and wrap up. If we have any other follow-on questions, you can either contact me directly through my contact info there, or if any pop into the queue after we wrap, the Silverlight Show folks will be nice enough to wrap those up and send them to me, and I'll follow up offline, and those will get posted with the session recording. So thanks everyone for attending, and feel free to contact me with follow-on questions.
Okay, thanks Brian for the great talk. There are no pending questions, so just remember that the demos, video and the slides will be available within 2 days on Silverlight Show. And thank you for attending. See you next time.